The following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
Example limiting reagent 2. If 5 grams of ammonia is treated with 5 grams of carbon dioxide to produce urea, what is the limiting reagent and excess reagent? 2. How many grams of the excess reagent remain? And 3. How many grams of urea are formed? Wonderful. To solve this problem, we'll begin here with number 1. To find the limiting reagent and excess reagent, we can begin by taking the masses here of the ammonia and the carbon dioxide, and we'll convert that into their moles, right, using their molar masses to find the amount of moles that are actually participating here in our reaction. And then from there, we can find the limiting reagent and the excess reagent. Great. Let's begin here with ammonia. Now, if we have 5 grams here of our ammonia, right, we know that the molar mass for ammonia, right, is going to be we'll round to 1 decimal place, and you can get that directly from the periodic table. It's going to be 14 for the ammonia, and it's going to be 3 for our hydrogen, giving us 17 grams. Should you require more information on how to find molar mass, we covered that earlier in this lecture series. Thus, once we go ahead and we equate the following, we end up with a value of 0.294 moles of our ammonia. Great. Now, let's just go ahead and highlight that. When we need to revisit that, we can. Next, what we'll do is we'll find the amount of moles here of our carbon dioxide, and we initially have 5 grams as well, right? Thus, if we take 5 grams of our carbon dioxide, and we know that the molar mass of our carbon dioxide is going to be 16 plus 12 from the carbon. That's going to be 44 grams, right? 44 grams of carbon dioxide. And once we go ahead and we equate this, I believe it's 0.114 grams here. Moles of our carbon dioxide. Great. There we are. Now what we do is we need to find the limiting reagent, and we can do so by here taking a look at our reaction here. We see that per mole of carbon dioxide that is reacting, 2 moles of ammonia are being consumed. Thus, if this amount of moles of our carbon dioxide is participating in the reaction, twice as much is going to participate for the ammonia. Thus, we can do a mole ratio down here, beginning here with our 0.114 moles of our carbon dioxide, and we just stated that 2 moles of ammonia are going to be used per mole of our carbon dioxide. This is going to give us a value of 0.228 moles here of ammonia as such. Now, what this number here is indicating to us is that in the following reaction, thus in the following reaction up here, right, in the following reaction with these conditions, when we have 0.114 moles of carbon dioxide that is being consumed, 0.228 moles of ammonia is being consumed, and we see here that we initially have 0.294 moles of ammonia. Thus, we're going to have some of this left over, right? And because of that, we know that the limiting reagent will be our carbon dioxide, and our excess reagent is going to be this ammonia. Thus, let's go ahead and write that in as well. This will be our excess reagent, right? And the carbon dioxide, that is going to be our limiting reagent. Wonderful. Now that we're done with number one, let's continue with number two here. How many grams of the excess reagent remain? Great. To find the amount of grams of the excess reagent that remain, and the excess reagent, as we said, is the ammonia. What we can do is we can take the amount of moles of ammonia that is being consumed, that we have down here, use its molar mass, right? Convert this into grams, then we'll know the amount of grams of ammonia that is being consumed, right? And subtract that from the initial amount, which is given to us up here as 5 grams, and we'll know the amount of grams of the excess reagent that remain. Great, let's do that now on the next slide. Perfect. Now, this is where we left off here, right? We said that we had 0.228 moles of ammonia that were consumed. Thus, if we begin with the 0.228 moles of ammonia, right? Excuse me, we can use now the molar mass, which we know is going to be rounded to 1 decimal place again, just for simplicity here, right? We know that's going to be 17 grams per mole of our ammonia, right, as such, and I believe that's going to be 3.88 grams here of ammonia. There we are. This number here tells us the amount of ammonia that is being used up. Now that we know the amount of ammonia that is being used up, we can subtract that from the initial amount that we have here, the 5 grams, right? And that's going to give us the amount of ammonia remaining in grams